This is Advanced Math, Unit 6, Lesson 2. Angle addition laws and solving for x. Angle addition laws and solving for x. Part 1, formula review. Okay. Eventually, and I've been telling you guys, you need to have these memorized, so I'm hoping that you've been working on them. Sine of A plus B, practice them every day. If you'd like, hit pause and see if you have them down memorized. I'm going to go ahead and continue. Sine is the friendly one. Sine of A, cosine of B, and the sign stays the same. And then we have, what is it? Sine of B, cosine of A. Now, you don't have to, I'm going to do it in a different color pen, or you can rewrite it in pencil. I'm just going to put it here. If this was a minus, then this here would change to a minus. If you don't like it, then don't write it with a different color pen and just rewrite it in pencil. Okay, next one is cosine of A plus B. Cosine is the snobby one. This is the one that is cosine with cosine. Cosine A, cosine B. The sign changes to the opposite, so it's minus sine of A, sine of B. Again, I'm going to use a different color pen. You do not have to. You can rewrite it in pencil if you'd like. If this had been a minus sign, opposite of a minus is a plus. If you don't like it, don't write it. Okay, and the last one is tangent. Tangent of A plus B equals, this is the fraction one, tan of A, if it's plus there, it's plus in the numerator, plus tangent of B, all over 1, and opposite is minus, the product of tan A and tan B. All right, changing it, if this was a minus sign, the numerator would be minus and the denominator would be positive. Okay, work on these daily. Don't wait until the day before the test, because we will still be learning more formulas throughout this unit. Okay, part 2, angle addition laws using Pythagorean's theorem. A squared plus B squared equals C squared. Angle addition laws using A squared plus B squared equals C squared. Okay, I'm going to write it the way you're going to see it in your book work as well as on quizzes and tests. Given sine of U equals 4/5, where U is in Q1, and cosine of V equals -12 over 13, where V is in Q2. These are your restrictions here. That's given information that will need to be given to you. They're either going to specifically tell you, or they will give you some kind of hint where you know which quadrant you're in. And you need to know which quadrant you're in because you will have to draw pictures. Okay, number 1, find sine of U plus V. Okay, so we have to draw pictures. So I'm going to do that here. Here's the picture for U, and here's the picture for V. Now, the reason I said this has to be given or a hint, because there's two places where sine is positive, and I wouldn't know where to draw it if this information was not given. Either they're going to tell you specifically where it's at, or they're going to give you some kind of hint on where to draw it. Okay, Q1, U is here, always by the origin, and sine is opposite over hypotenuse. 4, 5, Pythagorean's theorem, or you should have this one memorized. The missing side here is 3. All right, V, they told us where to draw it. It's in Q2. Why did they need to tell us? Because there's two places where cosine's negative, quadrant 2 and quadrant 4. So they need to either tell us or give us a hint. Okay, this is V, and cosine's adjacent over hypotenuse, keeping in mind that this is negative because it goes to the left and it tells us there. Pythagorean's theorem, you find that this side here is 5, and it's going upward, so it is positive 5. Now this is the picture we're going to use to find our answer, because when we did it in notes yesterday or the day before in lesson 6.1, they were numbers like 30 and 60, and we just evaluated them. Now we have to use our pictures. So let's use our formula first. Sine is this one here, the friendly one. Sine of U, cosine of V, same sign, plus sine of V, cosine of U. Again, this is a definite on the test, and we're just going to use our pictures. Sine of U, I go to the U picture. Sine is opposite over hypotenuse, 4/5. And yes, you could have used that from there. Cosine of V, we go to the V picture. Cosine of V is adjacent over hypotenuse, negative 12 over 13, and yes, we could have used it from there. Plus sine of V, you can see was not given. We definitely need our pictures now. Sine of V is opposite over hypotenuse, 5 over 13. Cosine of U, we're on this picture here, the U picture. Cosine of U is adjacent over hypotenuse, so 3/5. This gives me negative 48 over 65 plus 15 over 65. And they do have a common denominator, so I can go ahead and add, and that gives me negative 33 over 65. And that's the answer for number 1. And I said find, but I wrote fin. Number 2, find, not fin, find sine of U minus V. Find sine of U minus V. Okay, so we're going to use our sine formula, but now it's minus. So sine of U, cosine of V, take away sine of V, cosine of U. Okay, you technically can use these same numbers here, or you can go back to your picture to get practice. Sine of U is 4/5. Cosine of V is negative 12 over 13. Sine of V, where's V? Here's V. Sine is going to be opposite over hypotenuse, 5 over 13. And cosine of U, this one's cosine, adjacent over hypotenuse, 3/5. They are the same numbers, 4/5. You can see those there, only plus has become minus. So negative 48 over 65, take away 15 over 65, which equals negative 63 over 65. Okay, part 3, solve. Same thing we had on the last unit. 0 degrees is less than or equal to x, which is less than 360 degrees. Number 1, sine of x plus pi over 4 plus sine of x minus pi over 4 equals -1. All right, when you see these on the test, first recognize that these are both angle addition. There's an angle addition formula there. There is another angle addition one there. We have to expand. We are going to expand them. This expands to sine is the friendly one. Sine of x cosine of pi over 4. Same sign plus cosine of x sine of, sine of pi over 4 cosine of x. The way I was writing it before, you can write it that way. Okay, plus, I'll change colors now, plus, because it's addition, I don't have to worry about distributing a negative, so I'm just going to put the plus. Expand sine of x cosine of pi over 4, take away sine of pi over 4 cosine of x. So this one expanded is here in the blue color ink. This one here expanded is there in the pencil. And it all still equals -1. Okay, what is going to happen here? Do you see that these two are going to cross out? Sine of pi over 4 cosine x and negative sine pi over 4 cosine x are gone. Now, when you have these, there will always be something that you can evaluate. Notice that cosine of pi over 4 is a value we can evaluate from our unit circle. Sine of pi over 4 is another one that we can evaluate. Do you see that? So, before I do that, nope. Did I cross out the wrong ones? Gosh darn it. Yes, I did. Okay. Let me erase. Good thing it was in pen. I told you guys which ones we're going to cross out, but I crossed out the wrong ones. Sorry and sorry. Okay. Going back a step backwards. I said this one and this one, and I got carried away in my crossing things out. Sorry if I confused anyone. These two are the ones that cross out. These two are the ones that we can evaluate. Before I do, notice they're like terms. Sine of x, cosine of pi over 4, we add them together. It's 2 sine x cosine of pi over 4 equals -1. Okay, cosine of pi over 4 is something I can evaluate. Cosine of pi over 4 is 1 over root 2. Even before I evaluate that, can you guys see what I can do to the 2 just to get it to the other side? I'm going to divide it. 2's gone. Sine of x cosine of pi over 4 equals -1/2. All right. What is cosine of pi over 4? It's on our unit circle. Cosine of 45 degrees is 1 over root 2. The only thing I'm going to do is I'm going to bring it out as a coefficient. 1 over root 2 sine x equals -1/2. 1 over root 2 sine x equals -1/2. I'm trying to get sine by itself, so I multiply both sides by root 2. The root 2's are gone. I'm going to move over here. Sine of x equals -root 2 over 2. Those of you who write it this way, you're fine. Typically in a class, I do not write it this way, so I'm going to unrationalize. Sine of x equals, what does that become? Negative 2 over 2 root 2, because root 2 times root 2 is 2. 2 times root 2 is 2 root 2. So sine of x equals negative 1 over root 2. I'm hoping eventually you guys just recognize that root 2 over 2 is equivalent to 1 over root 2. What two quadrants is sine negative in? 3 and 4. Your reference angle is 45. What is 45 in these two quadrants? 225 degrees and 315 degrees. Okay, so a quick run through. We expanded each one. This one is here. The blue one is there. These two like terms crossed each other out because they're opposites. These two like terms added up to 2. Sine x cosine pi over 4. Divided the 2 over. The 2 is now gone. Cosine of pi over 4 is 1 over root 2, which I brought to the front. It's right there. Oh, right there. 1 over root 2. And then we multiplied both sides by the reciprocal. Crossed out, crossed out. Negative 1/2 times root 2 is negative root 2 over 2, which we recognize is equivalent to negative 1 over root 2. 45 degrees. Negative 225, 315. All right, number 2. Tangent of pi plus x plus root 2 cosine 3 pi over 2 minus x close parentheses equals 0. Whew, this is going to be a big problem. All right, let's expand each one because that's about the only thing I can do right now. Tangent is a fraction. Tangent of pi plus tangent of x all over 1. It's plus, so now it's minus the product of tan of pi and tangent of x. You can have your notes out from yesterday or last class session and know how to expand that. Plus root 2 times, and I'm going to put parentheses because I will have to distribute the root 2. Cosine's the snobby one. It stays by itself. So cosine of 3 pi over 2 cosine of x, opposite sign, so it's plus sine of 3 pi over 2 sine of x. Close parentheses, and it still equals 0. Let's work on simplifying this one. Tan of pi we can evaluate because pi is on the unit circle, and the tangent of pi here we can evaluate. All right, what is tangent pi? Look it up or you have it in your head. Tangent of pi is 0 plus tan of x all over 1 minus tan of pi is still 0 times tan of x. 0 plus tan x is just tan x. 0 times tan x is 0, so you have 1 minus 0. So this is just tan x over 1, which is tangent of x. Okay, so this expanded to this. This eventually simplified to tangent of x because 1 minus 0 is 1, and tan over 1 is tan of x. Okay, plus before I distribute, I'm going to go ahead and simplify the inside. Cosine of 3 pi over 2 is a quadrantal. Cosine of 3 pi over 2 is 0. So I have 0 times cosine x plus Sine of 3 pi over 2 is another quadrantal, and that is -1. So I have plus -1 times sine of x plus √2 times. Notice that all of this is going to become 0. Do you see that? All of this is 0 minus sine of x is negative sine of x. Okay, so what happened here? 0 times cosine is 0. Negative times sine is negative sine x. 0 minus sine x is just negative sine x. So 2 times negative sine, or √2 times negative sine, is negative √2 sine x, and all of this equals 0. Okay, so I have tan of x equals, or I'm sorry, tan of x minus √2 sine x equals 0. All of this to get to this point, which is right around where we were at last unit. We know how to solve these. I'm hoping you recognize to change this to sine and cosine. √2 sine x is going to stay. And then we have an equation. It's an equation, and I'm trying to clear a fractional equation. And I do that by multiplying everything by the common denominator. We've done that back in Unit 2. Common denominator being cosine. Cosine x, gone. Cosine x and cosine x. Okay, what does that leave me with? Sine x minus √2 sine x cosine x equals 0. And we can now factor, again, that's reduce sine x, nothing reduces, so it's √2 sine cosine equals 0. And we can GCF out a sine of x. Sine of x, parentheses, 1 minus √2 cosine x equals 0. And now we're able to use the zero product property. I'm going to go ahead and move it over here. Sine of x equals 0, so that's out here already factored, and then 1 minus √2 cosine x equals 0. When I solve this one, I subtract the 1 and divide the -2. Cosine x equals, it ends up being positive 1 over √2. Because subtracting the 1 makes it negative, dividing by the negative √2 makes it positive. Okay, there's two places where sine is 0. What two places is sine 0? 0 and 180. And there's two places where cosine is positive, quadrant 1 and quadrant 4. Your reference angle here is 45 degrees. So it's quadrant 1 is one of them, so 45 degrees. In quadrant 4, that is 315 degrees. So I have my final set of answers: 0 degrees, 180, 45, and 315. Again, a bit of a problem. It was pretty intense, but we expand, cleaned things up, kept cleaning up until we got here, and then changed it to sine and cosine, cleared it, GCF'd it, zero product, and solved like we did last unit. That is it for this lesson.